I want to introduce Jason, Dr. Jason Donev. He is the professor at the University of Calgary in the Department of Physics and Astronomy. And his interest is how to study and how people learn about science. And I thought that was rather an interesting twist. Never mind what science is, but how do we appreciate science? His other interest is nuclear energy as it pertains to this huge problem. And I think without further ado, I will ask Dr. Jason Donev to tell us what it implies to be energy literate.
Hello. My topic today is the importance of energy literacy, and as is always the case with professors, I am relying heavily on the work of a number of students who are making me look good. Specifically, Gokul Duran, Braden Heffernan, James Gendon, Ellen Lloyd, Jazdeep Tour, and Jacqueline Williams. If you are on Twitter, you can follow our project at nrg_edu. We are also on Facebook at energyeducation.ca, and there's a QR code there to go directly to the website, which is listed there. So what I'm going to talk about today is why we care about energy. I'm going to make a really, really odd argument that we shouldn't actually care about energy at all, and yet we need to. And I'll explain what I mean by that. Secondly, the world needs more energy. It's using more energy, and it's going to need even more energy, but there are problems with that need, and there are problems with the way we're meeting that need. And the third thing is I'm going to talk a little bit about creating an energy literate population. And of course, I'm limited in time, so I have lots more that I want to talk about, and hopefully that'll all come out in the questions, which will not be helpful for the TV audience, but we'll see what happens. So we don't actually care about energy. Energy is measured in calories, which all of us will be enjoying very soon, getting some calories in there. Gasoline is a form of energy, and we don't really care about gasoline. We don't actually care about electricity, and we don't even, unless we happen to have some investment in it, really care about natural gas. What we want, what we actually care about, are the services that energy provides for us. What we want is food. I don't want calories. I want chocolate cake. Yes! And truthfully, I don't really care about gasoline. What I like is being able to drive down from Calgary to this lovely city of Lethbridge. And I don't really care at all whether I'm doing that in a natural gas-powered vehicle, a gasoline-powered vehicle, an electric vehicle. It just doesn't matter to me. What I care about is travel. Gasoline is a means to an end. Likewise, I don't care about electricity. I want my iPod to work. I want my computer games to work. I want my television to work. I want lights so that I can read. And I don't really care about natural gas. I care about cooking. I care about a warm house. I care about taking a hot shower. What we care about is what energy gives us. And I like that framing of the energy conversation because when we define the problem properly, it becomes easier for us to discuss a realistic solution. Okay? So it's not energy, it's what energy gives us that matters. Okay? So, Dwayne, would you mind standing up for a moment? Now sit down. Now stand up. Now sit down. That's 100 watts. Thank you, Dwayne. I was going to do it to Cosmos, but I know Dwayne better. So that's 100 watts, which is the average output of a human over the course of a day. If you take a 2,000 calorie a day diet, you divide it by the number of seconds, put it in the right units, it turns out that all of us produce about as much power as a 100 watt incandescent light bulb. If you want to know what a watt is, you can just take your wrist, everybody go like this. I do this to my students too. And bend your wrist up and down. That's 1 watt of power. So when we talk about a 100 watt light bulb, we're talking about the same amount of power as 100 people, which is, you know, I guess if everybody did this with both wrists, that much power is going in to one of these light bulbs. We are using an awful lot of power. So you, as a Canadian, use 110, roughly, of these energy servants. So over the course of your day, the power that you use is Dwayne standing up and sitting down with 109 other Dwaynes also standing up and sitting down. So there's you, and there's your energy servants. This means that each and every one of us in Canada is roughly as rich in terms of the amount of power that we use as a king or queen in the 14th century. This is why we are so wealthy here in Canada. Now, the world average is only 20 energy servants, which means in terms of the amount of energy we use, the amount of power we consume, we are 5 to 6 times as wealthy as the world average. Okay? Now, I have this really strange notion. We're talking about reduction of energy use and so forth, and I'm all in favor of that. And I think we could probably reduce energy use by about 30%, which, when you couple the fact that the world's population is going to grow to 10 billion people and stop, it's very likely the world will hit 10 billion people. It's unlikely we'll hit 11 billion people. It's even more unlikely we'll hit 12 billion people. The common internet video that I've seen about exponential growth does not actually apply to the human population anymore. And if you want to find out more about that, ask me afterwards, because I have those slides but had to cut them. So we're going to wind up growing to 10 billion people. We can reduce our energy use by about 30%. That actually cancels it out. So if we want everyone in the world to be as wealthy as we are in Canada, that means instead of having the 16 terawatts of power, that's 16 trillion watts, we would actually need 80 terawatts. We would need 5 times as much power in order for everyone to have the standard of living that we have here in Canada today. Now, I think people really misunderstand the issue when we talk about energy. And I think the whole conversation is framed in a slightly misleading way, because we're framing it in terms of words, and these words wind up meaning something to the people who are saying it, but not to the people who are listening. Okay? Energy is needed to live the way we want to is a phrase that we in the energy sector or the energy education sector banty about all the time. And we just sit there and go, why don't people understand that energy is needed to live the way we want to? Or energy-dense fuels give a high quality of life. That's something I hear a lot in the nuclear industry. It's a very true statement. It's a very, very true statement. But what does it mean? Truth without context is useless. The developing world wants the same energy resources we have. And you know what? Market prices are going to get that. That's pretty clear. But these phrases don't say nearly as much as we think they do. And I'd like to show you what I mean by these phrases. On the left, we have how we keep warm here in Alberta. In my basement, I have a furnace that looks an awful lot like that, and a water heater, ironically, that also looks an awful lot like that. Okay? On the right-hand side, we have a little girl, probably about 11 or 12, keeping warm in Kathmandu. That's using biomass. This is keeping warm in the developed world. That's keeping warm in the lesser developed countries. This is what energy is giving us. Likewise, I have a stove that looks an awful lot like the one on the left. I got this out of a catalog, though. And on the right, we have a traditional 3-stone cook stove. And it's interesting to note that every woman and child in that household, generally it doesn't affect the men, but every woman and child in that household is getting the equivalent of 2 packs a day of cigarettes. Start them while they're still nursing, carry them on through. Okay? That is what cooking with biomass looks like. On the left is what cooking with electricity looks like, and I'm not going to get into the gas versus electricity argument on cooking. Please, let's not go there. Either way, it's the same. Okay? Energy-dense fuels allow us to have the left-hand side rather than the right-hand side. Now, the developing world wants our energy wealth. They want to have access to the same energy services that we have. And why not? It allows us to be comfortable. It allows us to be wealthy. When you look at the exact same room with the exact same man working at a sewing machine. Anybody here sew? Can you imagine trying to sew in that light? And I have students from these countries, and they say, yeah, that's about what those kerosene lamps look like. Trying to sew in that kind of light. Now, this is setting aside the fact these kerosene lamps fall over, they catch children on fire. Like, wow. On the right-hand side, we have a solar panel hooked up to a light-emitting diode, an LED light bulb. It is amazing what happens to the education opportunities when you start putting the right-hand side's electricity in. Literacy rates go through the roof. A colleague of mine formed a not-for-profit organization called Light Up the World, where he's an electrical engineer, and he's building these systems and getting them out into these developing countries. And a friend of his from Sri Lanka said, "My children had never read After the Sun Went Down before." Light lets us extend our day. Light gives us everything, which is why at the bottom of the poster behind me it says, "Fiat lux, let there be light." That is what electricity is giving us. So, electricity, it comes out of a plug in the wall. It's so convenient, it's so cheap, we don't think about where it comes from. And this is leading to a problem. So, my students put together a little website. And here, we have a simulation that my students created using data from the Energy Information Agency down in the US. And you've got a map on the left-hand side and a pie chart. And the pie chart at the moment shows the world's electricity generation. This is the actual website right here. And you can mouse over and see exactly how much the fossil fuels. So the red is the fossil fuels. That's where we're getting our most of our electricity from. The blue is the hydro. And the green is, anyone want to guess? No, coal is a fossil fuel, so that's in the red. Nuclear, yes. And everybody's talking about wind. Everybody's talking about solar. So the wind is right there. There's the biomass. There's the geothermal. And solar, tide, and wind are all that little tiny slice right there. Now this is a nice thing, and we can actually, oh, we're actually in 1999. Let's actually roll that forward to 2011. And we see, look, there's now a lot more wind. So in those 12 years, the amount of wind generation went up tremendously. Tremendously. Huge growth in wind, but it's still very, very small compared to everything else. And we'll talk in a moment why that is. But there's a really cool feature about this map because my students are awesome. Name a country. France. Okay, so we'll click on Western Europe. We'll go ahead and click on France, and that's where France gets its electricity from. Pick another country. Germany. That's where Germany gets its electricity from. Yeah, largely coal. Largely coal. Brown coal, in fact. Russia. That's going to take a second. Russia. 16% from nuclear, 16% from coal, and 2/3 of it comes from fossil fuels. Canada. Okay, click on the water to go all the way back out. Here is Canada. Almost 60% from hydro, 14% from nuclear, and 21% from fossil fuels, which is largely Alberta and Saskatchewan. And if you like, you can actually zoom in on Canada. And here is Alberta, 92% fossil fuels. There's Saskatchewan. Saskatchewan actually has a lot more hydro than we do. Turns out the entire province is tilted to the east. It's flat, but it's tilted. And there's BC. What about the US? Well, oh, there's Manitoba, by the way. The United States, I don't want to get too caught on this because I've got other things I want to say. But this is what always happens. People are like, oh my God, I had no idea. We could find out where all of our electricity comes from. So 2/3 comes from fossil fuel, roughly 1/5 comes from nuclear. And my students are so good that you can actually zoom in and find out where Kansas or Missouri or Illinois winds up getting their electricity from. So this is freely available online. And what I've discovered is that when the information is readily available like this, and I start showing people, people are like, wait, where's California's? And I actually have trouble getting the conversation going again about, we want to talk about why it's important for everyone to know this. Because people really do care. There's this attitude that, oh, people don't really care where our electricity comes from. Part of it is there's this huge information barrier that keeps us from getting the information because the people within the industry are not in any way being paid to be clear about where it comes from. What is the fastest growing energy source in the world? Solar. Any other guesses? Nuclear? No. Wind? This is coal. Okay? It is coal. So we have the different continents. This is also freely available on the encyclopedia that I'm putting together with my students. And you start with 1966 and you hit play. And of course, the height of the bar corresponds to the coal consumption. Starting in 66, the red is Asia Pacific. Immediately next to it is Europe and Eurasia. The purple is North America. And then in the 1990s, Asia starts using a lot of coal. And it keeps using more and more and more coal. So if we actually just graph that in a line graph, which you can also do on my encyclopedia, you see that coal is just going everywhere and taking over. Coal is huge and getting bigger. But it's not what we're talking about, right? It's not the energy source that people are always conversing about. It's solar, it's wind. But solar and wind are actually not growing as quickly as coal, which is most people's least favorite source of electricity. There's another view where you can actually look at a map, and we can, instead of going by region, we can actually go by country. And so here's the coal use by country, and if you click here, here is the coal use per capita by country, and once again, you can hit play, and you can actually watch that unfold. We're making all of this information available for free because we think, oh, that was the breakup of the USSR. The strange thing that happened there. Okay, and it's not just coal, right? We've got all the different sources. We've got geothermal, we've got hydroelectric, we've got nuclear, we've got oil. We've got total primary energy, we've got solar, we've got wind. You can look at the growth or the decline in the case of, say, nuclear in Japan, for all of them. You can also look at carbon dioxide emissions, and why you would want to look at that, we'll talk about in a moment. Actually, we'll talk about it right now. It's a little difficult for us to wrap our mind around a lot of scientific difficulties and a lot of scientific problems. There are almost 14,000 peer-reviewed scientific papers on climate change that have come out since 1991. 14,000. It is impossible for any one person to read all 14,000 of these scientific articles that are explaining why we know climate change is happening, why we know climate change is a problem, and why we know it's us. So international governments sent their top scientists together to work within their specialty on a panel. It was an international panel talking about climate change, and it was referred to as the International Panel on Climate Change. All of the world's leading experts got together and read the 14,000 papers as groups, and they went, yep, climate change is real, it's happening, and it's a problem. 24 papers, I think it's actually now up to 30, reject climate change. And of these 30 papers, my favorite of them is the one that pretends the Earth isn't actually rotating. It's actually very possible to read all 30 of those papers. If you're a real keener, you could even do it in a single day. Climate change is real. Climate change is a problem. Climate change is happening. Climate change has a greater scientific consensus than the cause of gravity. Speaking as a physicist here, we're actually a little more confused about gravity than we are about climate change. But, and I want to be really clear about this. Oh, sorry, wasn't ready for that. I want to be really clear about this. What is happening specifically with climate change is something that almost everyone gets wrong. So when Greenpeace, just to pick on a particular organization that drives me nuts, gets up and screams about, oh my God, all this stuff is happening with climate change and the world is going to end and everybody's going to be dead by 2050, they're wrong, and that's not actually what the IPCC says. What's amusing to me is that the IPCC has actually put out there their entire 1,400-page paper summarizing the 14,000 papers, 14,000 essays that were written into one volume that nobody ever reads. Well, that's not true. Lots of people do read it. But, and then they summarize it. And the FAQ, the frequently asked questions from the IPCC, is some of the best scientific writing I've ever come across. And yet almost no one reads it. And what does happen is people will say things like, you won't have peanut butter sandwiches anymore with climate change. No. Climate change will reduce the peanut yield, most likely, which will make peanut butter more expensive. Climate change does not mean the world is coming to an end. Climate change does not mean we're all going to die. But it is a complicated issue, and people on both sides are screaming. And it's important for us to sit down and know what is the problem and what isn't the problem. Now, greenhouse gases, which for the most part are carbon dioxide, followed by methane, are released when we burn fossil fuels. So every place where you're seeing that red corresponds to we are kicking out an awful lot of greenhouse gases. Coal produces roughly a kilogram of carbon dioxide for every kilowatt hour that you and I wind up using on our electricity bill. Natural gas is the cleanest burning fossil fuel, which to me is sort of like, I'd rather be shot with a .22 than a... Yes, natural gas is cleaner, and it's not just carbon dioxide. It's the methane, it's the NOx and SOx and all of the particulate matter and the mercury and everything else. Natural gas is cleaner, but I think it'd be a real lie to say that natural gas is actually clean, although that's certainly claimed a lot. When we talk about hydro, solar, wind, and nuclear, when you look at the entire life cycle of them, they do wind up producing greenhouse gases. Producing a solar panel does involve making greenhouse gases, but it is a whole lot less than the greenhouse gases from either coal or oil or wind. Okay? So yes, there are greenhouse gases associated with nuclear, with wind, with hydro. Yes, that is a true statement, but they are a lot less. Those are manageable greenhouse gases, and I would argue that things have gotten out of control with coal, oil, and natural gas. So why do we know the climate is changing? Well, here's a little picture from NASA showing the average temperature, and as you can see, things are getting a lot warmer. Things are getting warmer fastest up in the Arctic. Our friends up in the territories really kind of wonder where all this climate change denialism is coming from, because they're looking around in their front yard going, no, it's getting warmer here. But the other thing about climate change is that global warming is only one part of climate change. Increased storms and droughts and flooding and so forth, there are an awful lot of other problems with climate change. And in addition to there being an awful lot of other problems with climate change, there are also an awful lot of problems that are not climate change that also come from burning fossil fuels. Now, numbers are hard to imagine. I teach numbers, I'm a physicist, and when we say Alberta uses 4 gigawatt years of coal power, that turns into 32 million tons of coal per year. 1 gigawatt of solar is 400 square kilometers, 1 gigawatt of wind is 10,000 square kilometers. These numbers become meaningless even to me, and I consider myself an expert on numbers. So, let's put this in something we can understand. Here's our province of Alberta, and the coal, if it were on a coal train, would stretch all the way from Calgary, Alberta, to Sudbury. That's how much coal our province, just Alberta, uses every single year. A train that stretches here to Sudbury. Now, if we were to go nuclear, why am I in favor of nuclear? It's an energy-dense fuel. What does that mean? 4 truckloads of fuel would accomplish the exact same thing. Coal versus nuclear. It's an energy-dense fuel. Here's the city of Calgary. I'm sorry, I don't actually know how big Lethbridge is, so it was harder to do that calculation. Here is Alberta's electricity from solar panels. Now, for those of you who have ever tried to deal with land rights issues, trying to get this much solar panel out there would be a huge land rights issue. Doesn't mean it's impossible, doesn't mean it can't be done, but it's a non-trivial problem, which is physicist for it's hard. So here's Calgary. Here's the solar panel that I just laid out for you. And here is what Alberta's electricity grid from wind farms would look like. Wind and solar are not an energy-dense fuel. Wind and solar take up a huge amount of land and actually have a huge environmental impact because nothing's free. We always have to make our choices. And those three little things down there, that's the nuclear power plants or the coal power plants that you would need to produce the same electricity. It's difficult to get these numbers in context. That's a 1.5 megawatt wind turbine with a Boeing 747 in front of it, so you know how big these things actually are. A student of mine, I don't know if you can actually see this from back there with the lighting. Whoa. This is one tip. This is another tip. This is a car for scale. These wind turbines were being driven by train through downtown Calgary. They're enormous. So in order to get all this information out there, I have put together an encyclopedia that I call energyeducation.ca. We are currently in beta test, which means we've only got about a fifth of the content that we're hoping to have. We're hoping to be comprehensive. We're hoping to be the science behind the entire energy sector, everything from what is fracking and why does it matter, down to Fukushima, what really happened. We want to be as technologically and politically neutral as we can be, and we want to be visually driven, much like this presentation has been. This is the actual website right here, just energyeducation.ca. I propose that an energy-literate population is pro-energy, especially for the developing world. I think an energy-literate population is also pro-wealth. I want everybody to be as wealthy as I am. Let's have everybody win. And I think an energy-literate population understands that climate change is real. Informed people have different conversations about energy. We want to have meaningful visuals, things people can wrap their mind around. And I think we need both an Energy 101 course available for everyone, and I teach one if anyone's interested, and an encyclopedia. I'm making one if anyone's interested. So we need all of our energy sources. I'm not necessarily a big fan of coal, but if we shut off all of our coal plants today, people would starve to death in the dark. We need oil. I'm not a big fan of oil. There's a group going around Calgary with I love oil t-shirts, and I want one that says, I love oil, but I think it's time we start seeing other people. Thank you.